Okay, so we're now going to turn to trying to develop some more cosine identities based off of the one identity that we do have, which again is this cosine of a difference, is cosine of the first, cosine of the second, plus sine of the first, sine of the second. And so the first thing we want to recall here are these two identities for cosine and sine. Remember, cosine is an even function, so cosine of negative theta is the same as cosine of theta. And sine being an odd function, or in other words, symmetric about the origin, sine of negative theta is the negative of sine of theta. Turns out these two identities are the key, along with our identity here, to deriving the formula for cosine of alpha plus beta. That's what we're going to begin looking at here. So what we can do with cosine alpha plus beta is express it as a difference. That would be cosine of alpha minus a negative beta. See, now it's a difference, and so we can use the identity from up above, which would say that's equal to cosine of the first, cosine of the second, plus sine of the first, sine of the second. Okay. And then we invoke the identities from up above. Cosine of a negative angle is just cosine. So we can rewrite that first part there as cosine alpha, cosine beta. And then we can take a look here at sine alpha, sine negative beta. Sine of a negative is a negative, so that negative in the sine is going to come out front. And that'll actually make it minus sine alpha, sine beta. And so we have our second identity here, which is that cosine of alpha plus beta is equal to cosine alpha, cosine beta, minus sine alpha, sine beta. So it's the same format as the other one, except the signs are switched. Cosine of a plus is a difference, whereas cosine of a sum is, cosine of a difference is a sum. Okay. So now we have that identity, and we could use that to compute some angles if we added them. Like we already know how to do cosine of 135 degrees using a reference angle, but we could actually write cosine of 135 as cosine of 90 plus cosine of 45. That would give us our 135. Okay? Or we could compute, say we wanted to compute cosine of 105. Now 105 has a 75 degree reference angle. Fortunately, we don't know cosine of 75, but we could do 105 as 60 plus 45 and use this formula. So that's our identity for cosine. And then from these cosine identities, from our cosine difference identity up above, which let me just rewrite that again so we have them both together here now. Cosine of alpha minus beta, remember, is cosine alpha, cosine beta, plus sine alpha, sine beta. So that's just the second one. The first one we come up with, just writing that down a second time, because now I want to refer to that. I want to refer back to that one as well. So that way we have it right here in front of us instead of having to scroll up to look for it. Now, a while back, we had a result that we found way back in the beginning when we were looking at trig functions of an angle. And I think I might actually, yeah. It's actually back in one section even before that, I believe. Yeah, this idea of cofunctions. All right, cofunctions are angles that add to be 90 degrees. And what we found was that sine of that angle and cosine of its co-function angle, right? In other words, 90 minus that angle, they have to be the same. They have to be the same. And so we had that resolved. Well, another way of saying this is that sine of this angle is equal to cosine of 90 minus that angle, right? And so in a right triangle, that would always be true. Well, it actually turns out that that role is true in more general terms, and we're going to see that here by using our cosine of a difference identity. And so we revisit these. Now, these are not ones that you have to remember. They're actually going to be stepping stones for the identities that follow. So these two here, these cofunction identities, are not ones that you'll have to remember. But basically, we take cosine of a difference, and instead of having 90 minus the angle, we write it in radians. Cosine of pi over 2 minus theta. And look at what that'll be here using this angle difference identity. That's cosine of a difference is cosine of the first, cosine of the second, plus sine of the first times sine of the second. But cosine of pi over 2 is 0. So that would just be 0 times cosine of theta. That whole term is just going to disappear. Sine of pi over 2, sine of 90 degrees, is 1. And so we get this result that cosine of pi over 2 minus theta is just equal to the sine of theta. All right? Cosine of pi over 2 minus theta is equal to the sine of theta. Okay? And then manipulating this identity just a little bit, we can actually get a second one here. We can actually get a second one here. I'm sorry, I have the parentheses wrong on this. I just wrote that down wrong. The parentheses should be around the stuff inside there. Cosine of pi over 2 minus theta. So the second one, which is very much like it, is that sine of pi over 2 minus theta is equal to cosine of theta. And we can actually derive that from the top one. Basically, if we go in here and replace theta with pi over 2, watch what happens. Sine of pi over 2 minus theta, using this one right here, would be equal to the cosine of pi over 2 minus pi over 2 minus theta. All right, so what I've done here, just so it's clear, you can follow it, I've done sine of something. So I'm using this identity and say, well, that something is pi over 2 minus that something. So sine of that is cosine of pi over 2 minus that something. And then we distribute the negative sign through here, and we would get cosine of pi over 2 minus pi over 2. And when we distribute the negative here, we would have plus theta. So of course, equals cosine theta. So that just shows you real quickly that the second one here follows. So these are not two that you have to remember. These two are used to develop the identities for sine that we're now going to want to talk about. Right? And in particular, this first one here. Sorry, get that off there. Sine of something is cosine of pi over 2 minus that something. That's really the big one. The second one is just the other cofunction identity, and again, it actually comes from the first one. And so we're going to be using this identity right here to actually establish the identity for the other one here. But we'll actually need, as we're doing it, we'll actually need this as well. But the main one is this one here. Okay, so let's see how these two identities can help us now come up with similar formulas to this stuff right here, but for sine instead of for cosine. Because unfortunately, in the computations that we did, the sines didn't stick around in the derivation up in the previous video. So we consider that. What is sine of a sum of two angles? Well, this identity here says sine of anything is cosine of pi over 2 minus that anything. So sine of alpha plus beta is going to be cosine of pi over 2 minus alpha plus beta. Okay. Now, what I'm going to do here is I could go to my cosine angle difference identity and start putting that stuff in. Unfortunately, putting that stuff in will actually lead me with a sine of alpha plus beta, which is the thing I'm trying to compute, and it's not going to help me. So what we do here is distribute the minus sign around and regroup things. So we get cosine of pi over 2 minus alpha minus beta, and say that's the same as cosine of pi over 2 minus alpha minus beta. So I have an identity for the cosine of a difference, so I group the alpha with the pi over 2 and leave the beta out. And now we can use our identity for cosine of a difference, our very first identity here. Cosine first, cosine second, plus sine first, sine second. So cosine of pi over 2 minus alpha minus beta would be cosine of the first, pi over 2 minus alpha times cosine of the second, plus sine of the first times sine of the second. Okay, so sine of alpha plus beta follows down to this. This is still kind of messy looking, but this is where those two identities from just a little bit ago come into play. Right? We have cosine of pi over 2 minus an angle is just sine of that angle. So this stuff all just becomes sine of alpha. And sine of pi over 2 minus an angle is cosine of that angle. And so finally we have our identity here, that sine of alpha plus beta is equal to sine of alpha cosine beta plus cosine of alpha sine of beta. And so that is our angle sum identity for sine. And that is another one of the ones you will want to remember and be able to work with. Okay, now we're going to derive just one more formula, and that is the sine of a difference. Now, we could take sine of alpha minus beta, and we could do what we did here and say it's cosine of pi over 2 minus alpha minus beta and work through it that way. But here, sine of alpha minus beta, this last one we want to do, can actually use the first one again. So sine of alpha minus beta can be written as sine of alpha plus a negative beta. All right, that's another way to write minus. And then that's just sine of a sum, and we can just use the formula up above. And we get that it's sine of alpha cosine of negative beta plus cosine of alpha sine of negative beta. And then we're back again to our even odd identities. We're back once again to our even and odd identities. And so therefore we can go in here and say cosine of a negative is just cosine of that. And so we'll have sine alpha minus beta equals sine alpha cosine beta, because again, cosine of a negative is just cosine of that angle, dropping the negative sign. But sine of a negative beta becomes negative sine of beta, so that negative sign comes out front, and we get minus cosine alpha sine beta. And so here we have our last identity we're going to deal with right now, and that is sine alpha minus beta is sine of the first, cosine of the second, minus cosine first, cosine second. So we have these four identities now, and again, the real key idea is that every one of these is actually tied to this original geometric derivation here. The cosine of a difference is the cosine of the first, cosine of the second, plus sine first, sine second. So cosine of a difference is a plus, and as we've seen here, cosine of a sum is actually the minus. So it follows differently, and then the two sine ones that we're worried about follow the same format, except that sine of a plus is a plus, sine of a difference is the difference. Okay, so we're going to stop here now.